Hello everyone. In this section, we will construct a hypothesis test for the difference between two proportions of two different populations. So we have a population here, we may call it X, and another population Y, and we want to see if there is a difference between the proportion of X and Y. Probability of success or proportion of defected product and so forth. If we define the proportion as X, which is the number of success divided by N. So I take a sample here of size NX, and they take a sample here of size NY, and they define the proportion of success for the random variable Y as Y divided by NY, where X here is the number of success in this sample and Y here is the number of success in this sample. So from the central limit theorem, if the size of the sample nx time the probability of success px is larger than 10, then this random variable proportion is approximated by a normal distribution with a mean p hat and a variance p hat time 1 minus p over n. That's according to the central limit theorem. And if I construct a new random variable, which is the difference between, let's say, px minus py, then this also will be a random variable of normal distribution with mean equal px minus py and a variance of the variance of the random variable x and y. So that is px 1 minus px divided by nx plus py 1 minus py divided by ny. So these we have studied earlier. The only difference now in the hypothesis test, if I set my null hypothesis H0 such that there is no difference between the two proportions, then I am assuming in the null hypothesis that the proportion of the population X is the same as the proportion of the population Y. And in this case, then what will be the variance of this random variable? If I'm assuming this proportion the same, so am I going to use this variance? This variance is correct if no constraint on px minus py. But if I'm constraining them to be equal, then should I use for the variance this proportion or should I use this proportion since I'm assuming they are the same? In this case, we use the pooled proportion. And the pooled proportion is just the number of success in this sample, X, plus the number of success in this sample, Y, divided by the size of this sample, NX, plus NY. So when we calculate the variance with this null hypothesis, then we would use this proportion. So instead of px, I will put p hat. Instead of py here, I will put p hat. With that said, now we can construct the hypothesis test procedure as follows. So that's what we just said. Now, px, py, if the null hypothesis assumes these are the same, then the mean will be 0. And the variance, instead of this is px divided by nx and py divided by ny, now I use the pooled. So instead of having here px times 1 minus px, and here I have py times 1 minus py, now I'm going to have these, replace px by the p, add the pole, and take it out here and here. So I get this, times these, times these. And this will be the normal distribution of these proportion, assuming they are the same, because that's the null hypothesis we will be using. So with that said, this is the hypothesis test. Let me zoom this in. Let X be a binomial. So I have a two population, and here a manufacturer. So it's either you create a product success or failure. So they have a binomial. And if I take a sample here and they take a sample here, I calculated px hat, py hat, and here is nx and here is ny. And according to the central limit theorem, if you have at least 10 failure and 10 success in the sample, then I can use the central limit theorem. And this P will have a normal distribution. So now we compute Px as number of success in the sample divided by Nx and Py divided by Ny. And this is the pool for the proportion. So now when we calculate the z-score, will be these Px hat minus Py minus 0. So we don't include 0 because as before for the mean delta 0, and delta 0 could be any number. Here we are assuming there are no difference between them. So that would be 0. So we don't need to write it here. Divided by the standard deviation of Px minus Py. And this will be using the pooled proportion. And how we set the null hypothesis and the alternative hypothesis, we use the same rules we used earlier. We calculate Px minus Py, and this value, it could be either 0, a positive number, or negative number. If Px minus Py is positive number, so here is 0. If it's a positive number, it will be here. So then the alternative hypothesis will be this one, and the p-value will be to the right of the z-score, and that's the p-value. And the null hypothesis will be the opposite of h1, Px minus Py less than 0. Always oppose the evidence of the sample. And the same thing, if Px minus Py less than 0, then the area to the left. If z came here, then the p-value will be here. If they are not equal 0, that means the null hypothesis will be, for this one, equal 0. So now you calculate the two-tail. So this is 0. If z came here or here, you calculate these two-tail for the p-value. So let's take examples to find the difference between two proportions and reach some conclusion. A mobile computer network consists of computers that maintain wireless communication with one another as they move about a given area. A routine protocol is an algorithm that determines how messages will be relayed from machine to machine along the network, so as to have the greatest chance of reaching their destination. Assume that using a protocol A, so now we have two protocols, we want to compare them. Which one give a higher success rate of transmitting the data? So now we have a protocol A. So let's call this population X and this population Y, protocol B. Assume that using protocol A, 200 messages were sent and 170 of them were successfully received. So NX 200 and number of success X equal 170. Using protocol B, 150 messages were sent and 123 of them were successfully received. So Y is 123. So here we estimate the proportion of X equal 170 divided by 200, and this should give us 0.85. And estimate this Y proportion, it will be 123 divided by 150, and it should give us 0.82. So before we decide what is the null hypothesis, let's calculate the pooled proportion, which is X plus Y, so that's 170, plus Y 123, divided by NX plus NY, so that is 200 plus 150. And that pooled proportion is 0.837. Now I have everything I need to calculate the z-score. But before we calculate the z-score, we have to set our null hypothesis. And how we're going to set our null hypothesis, let's just see what is the sample, what kind of evidence does it give us. So let's calculate Px minus Py. So Px minus Py is 0.85 minus 0.82. So this is 0.03. So it is somewhere here. This is 0, so it is somewhere here. So the evidence shows that Px larger than Py. So I will go against the evidence. So the null hypothesis will be probability of Px minus probability of Y, or the proportion, is equal 0 or even less. And the alternative hypothesis H1 will be the opposite. probability of X minus probability of Y larger than 0. So here the null hypothesis, no difference between protocol A and B, and even though the sample shows some evidence that protocol A is better than B, but it's insignificant, so I will assume they are the same or maybe even less. So now we have to calculate this z-score to find this p-value. And if that p-value came very, very small, then I will have enough evidence to reject the null hypothesis. If that p-value came larger than 5%, 10%, then I will not be able to reject the null hypothesis. So to calculate the z-score, it will be px minus py, so that is 0.85 minus 0.82, divided by the square root of p. This is the pole p here hat. So that's p hat, which is 0.837 times 1 minus 0.837 times 1 over nx, 1 over 200, plus 1 over ny, 150. So these equal 0.03 divided by 0.03989. And these came 0.752. And I go to the z table, standard normal distribution table, and I look at z equal 0.752, which is somewhere here. And from that table, that p-value or alpha, it will come 0.226. So p-value equal 0.226, which equal 22.6%. So there is no strong evidence against the null hypothesis. So I cannot reject the null hypothesis, and I cannot conclude protocol B has the greater success rate. Okay, let's look at the next example here. The article factors associated with exercise behavior in people with Parkinson's disease reported a study of patients with Parkinson's disease of 164 patients who said they exercised regularly. 76 reported falling in the previous 6 months. So let's create our population. Our first population here, I will call it X patient exercise. And this population Y patient don't exercise. And they said of 164 patients who said they exercise regularly, NX equal 164, 76 reported falling. So X equal 76 in previous 6 months. Of 96 patients who said they don't exercise regularly, so NY equal 96, 48 reported falling in the previous 6 months. So Y equal 48. Can you conclude that the proportion of patients who fall is less for those who exercise than for those who don't exercise? So let's first calculate the proportion of failing for the patient who exercise, 76 divided by 164, and this should come 0.463. And the proportion of patient falling who don't exercise is 48 divided by 96, and this should come 0.5. Before we make the null hypothesis, let's just calculate the pole proportion. So this is X plus Y, patient falling from 2 population, divided by the total sample, NX 164 plus NY 96. So this is 0.4769. Okay, so now we have to set the null hypothesis. And to set the null hypothesis, let's see what the sample says. The sample says probability of X minus probability of Y, or the proportion, is 0.463 minus 0.5. So that is minus 0.037. So if this is 0, it's somewhere here. Okay, so the evidence shows it's less than 0, so automatically my null hypothesis would be the proportion of X minus the proportion of Y equals 0 or even more. That means exercising make no difference. The proportion of falling with patient exercising or don't exercise is just the same. Even though the sample showed patient with exercise fall less. The proportion is 0.463 versus 0.5, even though they small difference. But my null hypothesis, no difference, maybe even more. So the alternative hypothesis then H1 will be probability of X minus probability of Y, or proportion, less than 0. So now I have to calculate the z-score. It's proportion of X 0.463 minus proportion of Y minus 0.5 divided by the standard deviation of Px minus Py. So that is the pole proportion, 0.4769 times 1 minus 0.4769 times 1 over nx is 1 over 164 plus 1 over ny, which is 96. And if you calculate these, you get minus 0.037 divided by 0.064179. So the z-score equal minus 0.5765. And if I use the standard normal distribution table, minus 0.5 is here, and the p-value will be 0.2843. So the p-value is 0.2843, that is 28.43%. So there is no strong evidence to reject the null hypothesis. And my conclusion is there is no difference in the proportion of falling if the patient with Parkinson's disease exercise or don't exercise. The proportion of falling is the same. So exercise has no factor in balancing the patient with Parkinson's disease from this study. Okay, these conclude section 6.6. Our next topic will be section 6.7, which is building a test hypothesis for the difference between two means when we have only small sample. Thank you.